Every star in the observable universe is burning right now. Every single one. Scattered across 2 trillion galaxies in every direction, fusing hydrogen into helium across timescales that make the word ancient feel inadequate. Red dwarfs barely glowing, ticking along at temperatures a candle flame would find modest. Blue hypergiants burning so hot their surfaces reach 80,000 degrees, visible from halfway across the observable universe with the naked eye. Ancient stars, older than most elements. Infant stars still collapsing from their birth clouds, not yet old enough to have formed a stable core. All of them burning. All of them burning until right now. Because at this exact moment, simultaneously, without coordination, without sequence, without a single preliminary signal detectable by any instrument ever constructed, every star in the observable universe has gone supernova at once. Not a region, not a galaxy, not an unusual cluster experiencing elevated stellar mortality. Every star. The ones that were supposed to burn for another 10 trillion years. The ones scheduled to explode eventually anyway. The ones so small and cool they were considered effectively immortal on any meaningful timescale. All of them, at the same instant. As if the universe received a signal that physics cannot explain, and every stellar object in existence acted on it without hesitation. A single supernova is already an event of incomprehensible scale. In the first 10 seconds of a standard core collapse, more energy is released than the Sun will produce across its entire 10 billion-year lifetime. The core temperature reaches 100 billion degrees. The shock wave expands outward at 30,000 kilometers per second. The ejected shell of stellar material carries the mass of multiple suns, moving at 10% of the speed of light. A single supernova outshines its entire host galaxy for weeks. There are an estimated 200 billion trillion stars in the observable universe. All of them have just done that, simultaneously. The energy released in this single instant is a number that does not fit inside human mathematics comfortably. It is not that the number is unknown. It is that the number exists in a register so far beyond normal physical reference points that writing it down is more of a philosophical act than a scientific one. The observable universe has just converted the majority of its stellar mass into raw, explosive energy in a single coordinated instant. And the word explosion does not survive the comparison to what that actually means at this scale. The light has not arrived everywhere yet. That is the architecture of this event. Light travels at 299,792 kilometers per second, which is the fastest anything in the universe moves. And the universe is 93 billion light-years across. So the supernova light from stars on the opposite edge of the observable universe will take 46 billion years to cross the distance. The event is simultaneous. The experience of the event is not. It cascades. It arrives in sequence across billions of years, galaxy by galaxy, cluster by cluster, wall by wall, void by void. There is a place inside a collapsing stellar core, in the final milliseconds before the shock wave reverses and tears the star apart, where the density exceeds anything else in the observable universe, and no signal of any kind escapes. No light, no radiation, no information. The mechanics of what happens next depend entirely on the mass of each individual star. The smallest stars, the red dwarfs, were not supposed to be capable of supernovae under normal physics. Their cores never develop the mass required to trigger core collapse. Under normal physics, what is happening right now is not operating under normal physics, and the red dwarfs explode anyway, smaller and dimmer than their larger counterparts, but exploding nonetheless, adding their contribution to an event that has already broken the rulebook. The intermediate stars, the sun-like stars scattered across every galaxy in their billions, undergo a slightly different process. Their cores collapse into neutron stars, objects 12 kilometers across, containing more mass than the original star, spinning at hundreds of rotations per second, emitting beams of radiation from their magnetic poles that sweep across the surrounding space like lighthouse beams, pulsing with a regularity that is almost mechanical, almost deliberate, almost like a signal. Across the universe, in the wreckage of every former galaxy, billions of these pulsars begin spinning simultaneously, their beams crossing and intersecting in patterns of extraordinary geometric complexity. The universe, in the immediate aftermath of destroying itself, has accidentally become extremely organized. The largest stars collapse into black holes, not one, not thousands, billions of them, forming simultaneously across every galaxy, each one carving a gravitational absence into the fabric of space-time, an event horizon beyond which the laws of physics, as understood by any civilization that ever existed, simply do not apply. The density of new black holes forming across the universe in this single event exceeds the total number that existed across all of prior cosmic history. Space-time itself begins to distort at scales that were previously theoretical. Gravitational waves propagate outward from every galaxy simultaneously, intersecting, amplifying, creating interference patterns in the fabric of space-time that have no precedent and no name. The galaxies themselves begin to change. Without their stars, the gravitational dynamics that held galactic structures together over billions of years start to shift. Spiral arms, those elegant curved structures that took hundreds of millions of years to form through the patient accumulation of stellar orbits, begin to disperse. The shape of every galaxy in the observable universe is becoming something different, something without a classification. A universe of dispersing clouds and neutron stars and black holes and the slowly cooling debris of 200 billion trillion simultaneous explosions.